Hello everyone, welcome to Linear Models and Rates of Change. Welcome back. Today we'll be covering how to find the slope of a line passing through 2 points, how to write the equation of a line with a given point and slope, interpret the slope as a ratio and rate in a real-life application, sketch a graph of a linear equation in slope-intercept form, and write the equations of lines that are parallel or perpendicular to a given line. So, the pre-calculus that this is covering today is pretty much algebra and geometry. Once again, it's still pretty low. We'll build our way up though, okay? All stuff you do need to know though how to do calculus, and you might have forgotten over the last 3-4 years you haven't done this. So, first thing, slope of a line. Have a little triangle up there. We're going to be using this triangle all year long, and you should know what it means. The triangle is actually a Greek symbol. And remember, when I point to you, that's when you say what it is. And that Greek symbol means change. That's the delta symbol. So those of you guys going into fraternities or sororities next year, you see that? That is a delta. So delta means change. It is pretty much when you change something, the difference between two values. There's two types of change for a slope of line. The first type is vertical. Your vertical change is called delta y. That's the change in y. The change in your vertical distance. And remembering the formula, that should be what minus what? y2 minus y1, your second point minus your first point. The second type of change is horizontal change. That is your delta x. Delta x is, good, x2 minus x1. All right, so this is horizontal, left to right. The vertical is up and down. See? All right, so slope of line. This is a simple one. Define the slope of a non-vertical line passing through. Now, vertical lines are lines that go up and down. x1, y1, and x2, y2. This just means point 1 and point 2, two different sets of x and y values. Your slope equals rise over run. You remember those things? So the distance you go up and down over the distance you go left and right. Rise is your vertical change, so that's delta y. Run is your horizontal change, delta x. So you guys should know the formula for this is delta y is y2 minus y1 over delta x, which is x2 minus x1. And that is slope of lines. The slope is not blank for vertical lines. Now, a line that's vertical has that's the same. Has x2 equals x1, right? When these two are equal, the denominator equals 0, and you cannot have 0 as a denominator, or else the slope is what? Why can't these two equal each other? The bottom becomes 0, meaning it is not defined. You have an undefined answer. Anytime you have 0 as a denominator, undefined answer. Got it? Awesome. Find the slope of these points. Very simple. Go. All right, let's look. y2 minus y1, negative 5 minus negative 3. x2 minus x1, 11 minus 3. 5 minus negative 3 is 5 plus 3. Negative 5 plus 3, which is negative 2. 11 minus 7 is 4. Gives you negative 1/2. And that's it. Now, say I said, okay, this is my first point, this is my second point. And I flipped everything. I did, okay, negative 3 minus negative 5, 7 minus 11. As long as you do these 2 points first, or these 2 points first, and you're subtracting your x's and your y's, you end up with the same answer, negative 1/2. So it doesn't really matter which way you do it, okay, just that you subtract the 2 x's from each other, subtract 2 y's from each other. All right, so here are 3 different types of slopes. I want you guys to find the slope of problems 2, 3, 4, and 5. All right, let's check the first one. 1 minus 0, y2 minus y1, x2 minus x1. Gives you a slope of 1/5. What kind of slope is this? If you do it the other way, also still get 1/5. This is indeed though a positive slope. Positive slope are slopes that rise from the left to the right. Notice the slope is increasing from the left to the right. All right, and this just shows you, say I did, okay, 0 minus 1, negative 2 minus 3, same answer. All right, problem 3, negative 1 minus 4, 1 minus 0, gives you negative 5 over 1, or a negative 5 slope. That slope is negative. It is decreasing from the left to the right. And once again, if you did the other way, use the other points, reverse them, you would still get negative 5 as an answer. Now, horizontal lines, what kind of slope do they have? Well, 2 minus 2 over 2 minus negative 1 is 0 over 3. This is where some people get a little tricky. Not undefined. 0 divided by any number is simply 0. Now, a slope that's 0 is what type of line is this? a horizontal line. Okay, so it's zero slope, but it's a horizontal line. All right, this line right here happens to be a vertical line. So when we subtract them, what we say about vertical lines before, the bottom becomes 0. Anytime you divide something by 0, your answer is undefined. So it is a undefined slope. Vertical slopes are undefined. Horizontal is 0. Rising from left to right is positive. Falling from left to right is negative. There you go. There's like a month of algebra summed up in 2 minutes. All right, finding the equations of lines. Now, these are 2 other types of easy things to do. The first thing is a point-slope equation of a line. An equation of a line with a slope m passes through the point x1, y1, and it's given by the following. All right, so here's what you have to do. Remember what point slope is? Not y equals mx plus b. It's actually y minus y1 equals, let's see if you remember, m, the slope, times x minus x1. Now the y1 and the x1 are actually a real point, so those are numerical values, and you're looking, and m is also a numerical value. So let's find the equation that has a slope of 3 and passes through the point 1, negative 2. Plug it in there, see if you can get an answer. And put it in point slope form, not point slope form. Put it in y-intercept form. So y minus y1 equals mx minus x1, right? Negative 2, 1, 3. So y minus negative 2 is y plus 2. 3 times x minus 1. Okay? Now, what you can do further is, let's put this back into slope-intercept form, which is a useful one. So, distribute the 3. You get y plus 2 equals 3x minus 3. And you want y equals mx plus b, so we subtract 2 from both sides. Y equals 3x, negative 3 minus 2, minus 5. All right? Easy. Ratios and rates of change. The population of Colorado was 3,827,000,000 in 1995 and 4,665,000 in 2005. So over this 10-year period, the average rate of change of the population was what? So what is exactly rate of change? We're going to say change in P. What does P stand for? Population over change in time. Anytime you have a rate of change, it's always a change in something over change in time. It's always over change in time. So how do we find the population different between the 2 years? We want the population in 2005, the newer population, subtracted from the older population, which is the population in 1995. And that is going to be over what time period? 10 years. So population 2005, 4.665 million. 95, 3.827 million. Time period, 10-year time period. If it didn't say over this 10-year time period, you could have just did 2005 minus 1995, gives you 10. Subtract these two numbers. You get 838,000 divided by 10. And that is about 83,800 people per year. So the average change in population is it's increasing about 83,800 people a year. All right, but population usually doesn't go in linear. It's usually some type of exponential form. But this is just a very simple, basic rate of change. All right, let's move on. Why don't you guys try to find the rate of this? In a tournament, water ski jumping. Anyone ever water ski before? Me neither. The ramp rises to a height of 6 feet. The raft is 21 feet long, so you're going to jump over that floating ramp. I don't even know who would want to do that. The slope of the ski ramp is the ratio of height over length, rise over run. So, first thing I want you guys to do is decorate this nice picture by labeling the height and the width. Height and the length. Width is not a word. I was thinking of width and length. All right, so 6 feet high. How do we know? Height is 6 feet, 21 feet long. The slope is rise over run. 6, the height, over the length. 6 over 21. Now, here's the key. Can we reduce that? Yes, feet over feet. The units cancel out. What number goes into 6 and 21? Answer there is 3. 6 divided by 3 is 2. 21 divided by 3 is 7. So the ratio is 2 to 7. So for every 2 feet you go up, you have to have a length of 7 feet. So if I was going to extend this and go 2 more feet up, I'd go 7 more feet long, which would be about 28. All right, there you go. Set up little ratios for yourself. Right. Next one, number 9. Graphing linear model, sketching lines in the plane. So you got the slope-intercept equation in the line. The graph of the linear equation is a line having a blank of blank and blank at blank. It's a lot of blanks, right? Can you fill it in? Let's try. Graph of the linear equation is a line having a y equals mx plus b, right? That looks familiar? So what's your m? Your slope of m and a, what's b? Two words. Actually, a letter and a word. Y-intercept at 0b. 0 means you go 0 over from left to right. B means it's where you intercept the y-axis. So what this means is whatever this axis is, whatever b is, it goes on this axis. And then slope goes rise and runs from this point. So why don't you guys try these two problems? You're done? Very good. So let's look at the first one. In this case, y equals 2x plus 1, right? So your b is 1. So that means you start at this axis, you put a point at 1. Your slope is the thing next to the x. So that's 2 over 1. So from this point, I go up 2 and to the right 1. And what do I do with those 2 points? Did you say connect them? If you did, you are correct. Come on, this is 8th grade algebra. Y equals 2. So why are we doing it in 12th grade? Well, if you forgot how to do it, it's a quick little drawing of the memory. Y equals 2. And besides, the calculus book said you needed to learn it. All right, so y equals 2. We go over to y equals 2. It's pretty much 0x plus 2, so 2 is my y-intercept, right? Now, since my slope is 0, what type of line was that? That means 0 up and anything over. So that would be a horizontal line. Lines with 0 slope are horizontal. There you go. If this was x equals 2, it would go over to 2 and be a vertical line. All right, last one, you have to get y isolated by itself before you do anything. So what I'm going to do is I'm going to subtract x and add 6 to both sides. So subtract x, this cancels out. Add 6, this cancels out. You have with negative x plus 6 on the right-hand side. Divide both sides by 3. Y equals negative 1 over 3 plus 6 over 3 is 2. 2 is my y-intercept, so I put a little 2 there. Negative 1/3 means down 1 to the right 3. Positive means up, negative means down, and you always go to the right. So down 1 to the right 3, put my second point. And once again, like I said, connect the dots. La la la, right? Connect the dots. And we're good. Pretty cool, right? Pretty easy. I think so. You think so too. All right, so let's sum this up real quick. There are 5 general form, not general form. I was just telling you general form. There are 5 basic equations that you would use to describe lines. And remember, a line is straight. There's no curves in lines. The first type is a general form. So that's ax plus by plus c equals 0. Okay, everything's on the left-hand side. Vertical line, we just said before, is, an example, a and b can't be 0. So an example of this, and you don't have to copy it, is just 6x plus 7y minus 8 equals 0. I could put any numbers, fractions, decimals, anything I want there, as long as 0 is on the right-hand side. Right? Vertical lines is x equals a. A is any number. So x equals negative 9, x equals 0, x equals 12, x equals 1/2, x equals pi. It just has to be a number, okay? Horizontal line, y equals b. B is any number too. It doesn't necessarily have to be a different number. Y equals 1, y equals 2, y equals negative 3, y equals negative 1 billion over 6, 61. Y equals pi, okay, same thing. Point slope, we just did that. Y minus y1 equals m times x minus x1. So an example of this would be like y minus 6 equals 1/5 of x plus 6, right? So you can get the slope and you can get the point out of the line. Slope-intercept, the most famous and the most used and of all these slopes, especially in the algebra, is y equals mx plus b. Y equals negative 1/2 x plus 10. All right, so these are the points. These are actually, the equations that you would use to justify a straight line. Right? Now, lines can be 2 things, and these things you have learned in elementary school. But this is a little expansion of it. The 2 things you can have with lines, if you have a pair of lines, they can either be parallel They can be perpendicular or neither, okay? If they happen to be parallel, what is true about M1, M2? M here represents your slope. Well, if you don't know, find the slope. What is the slope of M1? Let's see, pick a point. I'm picking this point right here. Rise, 1, 2, 1. 2 over 1, the slope is 2. What is the slope of this one? Let's go from this point up to over 1. It's also 2. So the slopes are equal. Anytime you have parallel lines, they have the same slope. Parallel lines are lines that are on the same plane and never intersect. So M1 equals M2. Okay? Now, perpendicular lines are just slightly bit different. The way they work is they do intersect. Intersect means the lines cross each other. Perpendicular lines are also on a, the symbol are like little arrows without the back. All right, so perpendicular lines here. The slope of this still is 1, 2 over 1. What's the slope of 2? Well, this one is actually going down and over. So -1 and 2. So it's -1/2. What do you notice about the slopes? They are blank, blank. Do you remember the words? Positive and negative are opposites. And 2 over 1 and 1 over 2 are, word begins with an R, reciprocals. They're opposite reciprocals. So M1 equals a -1 over M2. That's it. Simple as pie. Now, if M1 was negative, this one would just be positive. If this was positive, it would be negative, and so on. Perpendicular lines are also lines that always form a right angle. Okay, where they intersect, they form 90-degree angles. Got it? Let's move on. General forms of a line. I want you guys to tell me. Find the general form of the equation of the line that passes through point 2, -1, and are parallel to the line. 2x minus 3y equals 5. So, try it on your own. You want some hints? Here's some hints. Parallel lines have the same slope. So the first hint is to find m of your original equation. So isolate y. Okay, let's see if you did it. Slopes have to be the same. You get y by itself. Y equals mx plus b. I start with 2x minus 3y equals 5. So you get y by himself, I, or herself. Subtract 2x from both sides. You get -3y equals -2x plus 5. Divide both sides by -3. You get y equals -2 divided by -3 is positive 2/3 x, plus and minus is -5 over 3. So the y-intercept here does not matter. All that matters here is the slope. The slope is 2/3. So since the slope of my original equation is 2/3, the slope of the parallel equation would also be 2/3 as well. Now we're going to use this equation and this line to find my new equation. So we said y equals mx plus b. All right, we need to find out what b is. We know what m is. What's m? 2/3. Do we know what x and y are? Do we know what x and y are? Of course. We know that x and y are the 2 points, the point that it passes through. So it's x is 2, y is -1, and slope is 2/3. -1 equals 2/3 times 2 plus b. 2/3 times 2, 2 times 2 is 4, and 3 times 1, which is the placeholder here, is 3. So remember, you multiply across the tops. -1 equals 4/3 plus b. I subtract 4/3 from both sides, and when I do that, this becomes 3 over 3, -3 over 3, minus 4 over 3, so you subtract the numerators, the denominator stays the same. -3 minus 4 is -7, 3 remains 3. Okay, now this is how it worked again. -1 is -3 over 3, so -3 over 3 minus 4 over 3, -3 minus 4 is -7, and the 3's remain the same. Last step, plug everything back into your slope-intercept equation, but not the x and y. So y equals m, which is our new slope, which is 2/3, plus b, which is -7 over 3. And that's it. Isn't math easy? See, I'm doing this trying to figure out how to show the next lesson, which is going to be a tricky one. All right. Problem number 13. Find the general forms of the equation if the lines that pass through point 2, -1 are, now we're doing perpendicular. Okay. Step 1 is still the same. Find the slope. I'll give you a hint. Same slope as before. Now the slope here, perpendicular, is the negative reciprocal. So in order to find the slope of this equation, just like we did with the equation that was before it, you're going to subtract 2x from both sides, divide both sides by -3, and once again it is 2/3. Do you know why it's still 2/3? Because it's the same equation as number 12. But now, m1 is 2/3, m2 is -1 over m2. So what that means is I have to reciprocate this and change the sign. So it's -1 over 2/3. So the reciprocal of 2/3 is, you got it, 3/2. Now, what does this mean over here? It means that if I take something and divide it by a fraction, I take a number divided by a fraction, what pretty much happens is the second denominator moves to the numerator. A divided by B over C is the same as A times the reciprocal C over B, so it's A times C over B. That's why it's 3 times 1, which is 3, over 2. All right, same step as we did before. Find B. We're going to use, once again, our x and our y. So y is -1. X is 2. M is -3/2. 3 times 2 is 6, divided by 2 is 3. So -1. -3/2 times 2 is -3/2 times 2 over 1. 2 times 3 is 6. -6 over 2 times 1 is 2. 6 divided by 2 is 3. Bam. Add 1 to both sides. -1 plus 3 is 2. And that's our B. So we're going to take our M and our B and plug it back in here. Y equals -3/2 x plus 2. Bam. And that is solving perpendicular lines. Ready to do one more? I do. Problem 14. And then we're done. Last one. Find the line that is perpendicular to this right here and pass it to that point. Let's see if you got it. All right. Steps you should have followed, the same ones we just followed for number 13. Find M. So you're going to isolate y by itself. We want the negative reciprocal of whatever this m is. 5x plus 2y equals 7. Subtract 5x from both sides, right? 2y equals -5x plus 7. To get y by itself, we divide everything on the right and the left by 2. -5/2 x plus 7 over 2. -5/2 is our slope. The negative reciprocal of this is -1 over -5/2. So we switch the sign here, it becomes positive, and you can just flip the 5 over 2 and make it 2/5. Okay? Or you can use this fancy little thing I just showed you. I always usually just flip, negative goes to positive. Plug this in. Find B. We're going to use x is 2, y is -3, m is 2/5. 4 times 2 is 8 over 5. -3 minus 8 over 5. So -3 is the same as -15 over 5 because you need a common denominator. -15 over 5 minus 8 over 5 equals, negative and a negative means you combine these terms to get 23. 5 stays the same. So -23 over 5 equals your B. Last step, plug it back into the equation. Y equals new slope, x plus -23 over 5. You don't need the plus minuses. So 2/5 x minus 23 over 5. All right, it's a nice, easy way. What we just did was just establish some little geometry and algebra. Got you guys mathematical juices flowing again right now. And the next lesson, I think we're going a little graphical. So it'll be a little tricky, but it should not be that difficult. Okay, so till the next time, I'll see you later. All right, hopefully you learned all this stuff.